Hi guys, in this video we're going to be taking a look at all the things that you can do with the array modifier. First of all, how to access the array modifier. Come over to the properties panel and select the modifier properties tab. It looks like a tool wrench. Then come over to the add modifier option and left click. From this menu, select generate, and then the very first option will be array. Note that this menu is in alphabetical order, so as it starts with A, just left click where it says array, and this will add the array modifier to your scene. So what tool does the array modifier mimic? Well, it mimics the duplicate and duplicate linked tools. If you go to the object menu and come down to where it says duplicate objects, you can create a duplicate of your current selection. This is effectively what happens with the array modifier and its parameters. For the moment, I'm just going to increase this X value here so that there is a little bit of a gap between the original object and the duplicate. Now there is a difference in how the array modifier affects your scene and your selected object depending on whether it is active or if it's applied. Currently, it is active, and while it is in this state, it acts like the duplicate linked tool. This means if I go into edit mode and manipulate the geometry of the original mesh, for example, let's go into edge select, take this edge here and move it up on the Z axis, you will see the change is mirrored on the linked duplicate, which is part of the array modifier. However, if we return to object mode and then we go here and select apply to apply the array modifier, you will notice that this time they are both still selected, and if we press the tab key, they are effectively independent of each other. Now this is not exactly the same as the duplicate objects tool, which allows us to create two unique objects, but it is similar in the sense that we have two meshes that are part of the same object that can be edited independently of each other. So we can manipulate this mesh without manipulating this one here. If you did want to separate them, simply select everything, then press the P key and choose separate by loose parts. Now you have two models that are independent of each other. Let's now take a look at the actual parameters that we have in the array modifier. We're going to skip over the fit type because the most important one to note is the count. This represents the total number of instances, if you like, of your selected object. This count includes the original object. So even though when we highlight it, it tells us the number of duplicates it plans to make, this number does also include the original object. So if I set this to 1, we only see the original mesh, and this is the same as the array modifier effectively not working on our model. So it needs to be a minimum value of 2 for the array to take effect. Now below that we have several different options for how we want to space out each duplicate of our array. Let's start with relative offset. Relative offset takes into account the dimensions of the original model. For example, we have the factor X value set to 1, the Y set to 0, and the Z set to 0. The X value is set to 1, and this basically means that we are moving the array across on the X-axis alone. The value of 1 means that we move it exactly 1 length across. So the original cube object, if we open the side panel, was approximately 2 meters. If we bring this back down to a count of 1, we can see it's around 2 meters along the X-axis. This means that whenever we create a duplicate, we move that duplicate 2 meters across on the X-axis because we are using the dimensions of our original object here. To create some space, all we need to do is increase this value to be greater than 1. So now the distance is equal to 1/10 the length of the object on the x-axis. We can click and drag to further manipulate where our object is going to go whenever we increase the count value. We can also do this on the y-axis as well as the z-axis. So we can move our array across in 3 dimensions. The next option is to use the constant offset. So I've unticked relative offset and I'm going to close it up. Then I'm going to open constant offset and left click. This uses the unit of measurement defined for the 3D viewport itself. For my instance of Blender, I'm using meters. You can see here that we have the distance value on the X, Y and Z axes. It's currently set to 1 meter on the X axis. If I increase this value, you'll gradually see that the second count is being pulled out, but it's still all connected. Remember, the actual length of the cube here is 2 meters. So we're going to need to increase the distance on the x-axis to over 2 meters if we want to see a gap between each instance of the array. Again, we can manipulate all 3 of these values to send each instance in any direction on all 3 axes. Then we have object offset. Object offset allows us to define the distance from the current model depending on the location of a target object. For this demonstration, I'm going to create an empty. I'm going to choose plane axis, although you can choose whatever one you want. And I'm going to move that empty object along the Z axis. And let's go to about 3 in the side panel. Now you can use this with any object type, but it's typically most commonly used with empty objects that you will not see in any render and do not have any influence on your scene other than with your array modifier. So here I'm going to choose object and then choose empty. Now you can see that we have created our array and the first instance is actually positioned where the empty is. I'm going to go to my empty object and select it in the outliner panel, and then I'm going to drag the empty. Note that I'm not actually moving this mesh because I can't even select it, but I am moving the empty object that it is being used as a reference for its new position. Now I can come back to the original model and we can increase our count, where we can see that we can continue to manipulate the positioning of our instances based on where the empty is. Again, just keep in mind that because your first instance is going to be in the same location as your empty, it's far easier to select the empty object in your outliner instead of in your 3D viewport. Now we'll return to the fit type parameter. So far we've just used fixed count, but there are 2 other options, fit length and fit curve. Let's take a look at fit length, and this basically allows you to define a max length of your array. Currently it's set to 0, but let's see what happens if we set this to 10 meters. If we zoom out, you can see that our array moves across that length of approximately 10 meters in the 3D viewport. Now at the moment, our relative offset is again set to 1, so let's create a gap by increasing the X value. As soon as I do that, you may realize that the total length decreased. This is because we are trying to fit as many instances of the model within that defined length as we can. if it reaches the point where we can only fit 5 cubes in because we can only move up to, say, 9 meters, and we wouldn't have enough space for the 6th, then it's not going to try and add that extra cube in. I can increase the relative offset, and eventually it will reach a point where it deletes another instance. So the greater the value here in the relative offset, the fewer cubes are going to be added as a part of the array, because they need to fit within this parameter here. Then we have the third fit type, which is to fit along a curve. Now, for this example, I've recreated the cube as what is effectively going to be a wall, and I'm going to fit this wall along a curve object. So here I've added in what is known as a Bezier curve, and I'm going to use the array modifier along with a second modifier to fit this object along that curve. The second modifier that we need to use for this to work is going to be the curve modifier. But before I do that, I need to define the curve target. So just left click, brings up a menu, and I'm going to choose Bezier curve. At this point, my original wall object, and I'm just going to rename it for reference, is going to adopt the same length as my Bezier curve. But it's not going to curve like the object here, and it's not going to match its positioning with the Bezier curve either. I should also note for this example, I'm using a cube that has a lot more geometry so that it can bend around the curve more easily. Now I'm going to add a second modifier, which is going to be my curve modifier. So this is going to be found in the deform section. Select curve and make sure it's below your array. Then we're going to choose the Bezier curve as the object, and it should snap into place along the curve. So the fit curve option for the fit type of the array modifier requires that you assign a curve target and that you also combine it with the curve modifier, where again you choose the same curve target. You have the opportunity to change the deform axis if you wish, but keep in mind that typically only one of these options is going to be correct depending on the transform values of your model. In our case, the best option was in fact the x-axis, so we'd keep it at that. The merge parameter in the array modifier allows us to connect the geometry that is within a certain distance. In this example, I've got a single additional instance of my mesh. Now, if I was to apply this modifier, hit the tab key to go into edit mode and select a vertex in the center here and press G, you can see that we can select that geometry and manipulate the instance independently of the original, even though the geometry is actually overlapping. So if I press the L key and press the G key again, I can manipulate that instance. But what if I wanted this geometry to be merged together? Well, I'm going to use Control Z until I get the array modifier back. Then I'm going to enable the merge option. Open this up and you can determine the max distance. Here I'm just going to increase it slightly just to guarantee we get merging. And we also have the option to determine the distance and the merging for the first and last copies. We don't need to tick that in this example, so we're going to leave it off. And now I'm going to apply. If we press the tab key and then select the same vertex and press G, you'll notice the behavior is very different because we merged the overlapping vertices in these positions. Let's look at a second example of using this merge functionality. Again, we have a wall object here that has a lot of geometry. We're going to add two modifiers to it. The first one is going to be the array, And we're going to set this to fit a curve, and the curve object is going to be the Bezier curve. Then we're going to add a second modifier, and this is going to be under the form, curve, and select Bezier curve. So now we have the curve applied to our wall. If we were to apply both of these modifiers and hit edit mode to go into our object's edit mode functionality so that we can select all of the geometry and press the L key at any point, you would see that we are still able to manipulate the individual islands or instances of the geometry we created with the array. But again, let's say we wanted to merge this all together. We're going to bring back both our modifiers, enable the merge functionality, and I'm just going to increase the distance slightly. Don't want to go too far with this one because we've added a lot more geometry. And then we're going to once again apply both of these modifiers. This time I'm going to go into edit mode and press the L key again. Now the entire model has been selected because everything has been joined together. This is now one coherent mesh from start to finish. The merge tool also has the ability to connect the start and end points of an array. For this example, I've created an empty object and I've rotated it by 22.5 degrees on the Z axis. Next, I'm going to add my cube object, and I'm going to also add the array modifier. I'm going to turn off relative offset, turn on object offset, and we're going to use the empty object. So now this creates an instance that is rotated 22.5 degrees. I want to, with the cube selected, then go into edit mode, and then I'm going to move the geometry of the object along the x-axis. I'll use a value of 6 for this example, and that should line up the inside vertices here. Then I can just increase my count value until I go all the way around, and the count value should be around 16. Then we're going to hit the tab key to move back into objects mode, and here we're going to enable merging. Now this should merge all of the inside vertices, but what about the outside vertices? Well, in order to bring these together, we're going to need to activate the first and last copies option, but before we do that, we're going to need to increase the distance value. And once we reach a certain point, all of those vertices should merge together, with the exception of the first and last instances. And this is where we would turn this option on to snap them together and merge them in place. With that done, we would then be able to apply our array modifier, then move into edit mode where we can preview our geometry, which has now been merged together thanks to the array. When creating an object, you will traditionally create the object first and then move on to the shading and texturing phase. However, you may apply a modifier such as the array after you have added your texture. So in this example, if I go to Material Preview, you can see we've added a texture to this model. There's a little bit of an overlap here where we have the next part of the array. Now this next parameter is going to be useful depending on the type of texture that you are using, and it allows us to adjust and offset the UV values. UV basically is a representation of your texture maps in 2 dimensions. So if I go to UV editing, you can see we have the UV map of the initial model and a texture map behind it. So here we'd be able to manipulate these UVs. So we go U in one direction, V in another. And this would change the way in which the object's texture is mapped to its surface. Now if we go back to the array modifier, this will effectively change the way in which we map that texture on each instance. So if I increase the count to 2 and then change the U value, you can see how it shifts the pattern on our second array. So we can change the U and V values to get a new result each time. This can be useful in an array such as this, when, say, we're creating multiple rocks and we want each rock to look at least a little bit different. Then even using the same texture, we can manipulate the offsetted UV values for each of our created instances for a new result. Finally, let's take a look at the caps option in the array modifier. We can determine a cap start and a cap end. Now for each of these, we're going to need to define another object. Now because we need to define another object, it's important to remember which offset type you are going to be using. Our base object is going to be a cylinder, and you can see in my example, we currently have a second count. We're going to reduce that to 1. And actually what I'm going to do is I'm going to remove that top face for this example, because we don't want overlapping faces, which can occur when working with our geometry. That's another little tip when working with the array modifier. Make sure there's nothing overlapping. And from here, we're going to increase the count, and then we're going to add to this count a starting cap and an end cap. So this object here may be the end cap, and this one may be the starting cap. So the start cap, we're going to go with cylinder.001, and it's going to position it at the bottom here. And then we're going to choose cylinder 002 at the top. Again, this is taking into account, in this example, the relative offset of the current main object. So if I was to take this object here and scale it down on the z-axis, initially there's no change to the application of this cylinder on our main model. However, watch as I go to apply the scale. There's now going to be a gap here. So obviously you can fix that after you apply the array modifier, but just keep that in mind when you are going to be manipulating the geometry of the start and end caps. An alternative here might be to adjust the object in edit mode. So if I hit G, then Z, I can manipulate it in real time for both the main model as well as the cap that is being used for the array. So here I'm just going to bring it up to about here, and that should work nicely for my main object. By the way, in case you couldn't tell, this is supposed to be a rocket ship, but it could also double up as something like a pencil. So that's about it with the array modifier. There are many different things that you can do, but at this point we have covered all of the key parameters within the array modifier itself, and I hope to see you in the next video.